First example. For a circle that has a radius of 45 centimeters, what angle corresponds to an arc length of 12 centimeters? Can we come up with a quick picture for what this problem is asking? We've got a circle. Our basic relationship between the angle of rotation, the radius of the circle, and the arc length, and information given to us was that our arc length was 12 centimeters and that the radius of the circle is 45 centimeters. We would like to come up with the angle theta. So we have S, we have R, we're looking for theta, so we could use the formula S equals R theta. It's a good choice because S and R are known, theta is unknown, that's the angle that we're looking for. Let's solve this equation for theta, basically dividing both sides by R, and I have quantities I can plug in place of S and R. It is important, just like it is important for us to always remember that theta must be in radians, our measures of distance have to all have the same units. So they don't specifically have to be feet or meters, but they have to agree. So since S is in centimeters, radius must also be in centimeters. We're in good shape there. I can do this divide. It's going to give me a repeating decimal, so I'll keep it as a simplified fraction for now. But what units will we have now? Our units of centimeter have canceled. We know that this is theta, which will give us automatically answers that have units in radians, so definitely I can call it 4/15 radians. The radians is a dimensionless unit, so when we see these two units of distance cancel each other out, radians kicks in as really just a ratio of distances. What I would want you to think about going forward is when we solve for theta, it will always be in radians. And what we'll see with our units is actually our units in the fraction cancel one another, and we're left with no visible units. We can put back radians. We may be interested in a decimal approximation. It was about 0.27 radians. Now what if we want an answer in degrees? What angle in degree measure? 4/15 radians, let's do a unit conversion. I like to, when I'm converting units, always multiply by fractions. And I think a lot about the units that I start with. We're starting with radians. Radians, this unit is like it's in the numerator, so I want to cancel it out by having radians in the denominator and degrees in the numerator. Each of these fractions, it's going to be a unit fraction where I basically show the equivalence between two units. So I could put in here something about how many radians equals how many degrees, like 360 degrees equals 2 pi radians, or 180 degrees is 1 pi radians. I like that one. But I'm guided by starting off with radians, knowing that I want to get rid of that unit of radians and have degrees left over. So my degree unit is up in the numerator in this unit fraction. The radian units will cancel. I'll have degrees for my units for the answer. I'm trying to stay exact, so I'm keeping this in terms of pi. I just noticed that 4/15 times 180 equaled 48. So as an exact degree measure, 48 over pi, and as a decimal approximation, about 15.28 degrees. Now we're building up a flow through these problems where we examine what information is given and determine which of those formulas we should use. But there will be multiple paths through these problems, and at times you might even see a way to find the answer that doesn't use those formulas. For example, this problem, our circle had radius 45 centimeters, so what's the circumference of a circle? The 2 pi r formula. So if the radius is 45, then our distance around the circle, the circumference or the perimeter of that circle, would be 90 pi centimeters. Now we're talking about an arc length of 12 centimeters. So I could say, well, what fraction of the entire circle is that? 12 out of 90 pi. So our arc length S is this fraction of the total circumference. Now we're trying to come up with what angle measure does that correspond to. If I have just established that our arc length is this fraction of the total circumference, then the degree measure is also this fraction of our total degrees in a circle, 360 degrees. Okay? So what I did was I said, I know the radius and I know the arc length is 12. I could figure out what the total circumference is. So the arc length we're interested in is this fraction of the total circumference. Therefore, the angle is that fraction of our total angle measure in a circle, 360 degrees. So I do this multiplication, 12 over 90 pi times 360 degrees equals the 48 over pi, or approximately 15.28 degrees. So I didn't specifically use the S equals R theta formula. I used some ideas, kind of like a proportion actually, about, well, the arc length is what fraction of the entire circumference. It corresponds to some angle that is a fraction of the total 360 degrees. Going forward, we will really stick to identifying which of those formulas we could use, but understand it's not required, and that often in these problems we can see some other pathway through these problems that will get us a correct answer.